Okay, I'm going to go ahead and start. First thing we're going to look at today is because you guys that had the previous Cisco classes, the look and feel of the online networking academy for the individual courses was a little different. And on this one, it's not immediately obvious to you where the ebook is, so I'm going to show you that. So I have a special student account I've created, which kind of looks like what your student accounts are. And this is our course here. So I'll launch the course. And sometimes he'll pop up a screen. He'll ask you to re-log in or redo your password, something like that. So there used to be a thing you can click on that goes right into the course. Well, on this one, he gives you a little hint here. He says, go to the modules section. You can click here, or you can click here. And the course content is here. Switching, routing, and wireless essentials course, and it's going to force you to open it in a new window. So here's the online ebook. We're in chapter 3. You can go to the individual things. Now there's a cute little index up here, course index, where let's say, for example, I just want to see the videos. And there's a couple chapters later on where it's almost all videos. I'll have you guys watch the videos on that one. So I can scroll through here. There was a little video about frame forwarding for the last chapter we covered. In the chapters about the wireless controller setup, there's a whole bunch of videos. I'm gonna have you guys watch that when we get to that later chapter later on in the year. Now, the course assessments, the quizzes are not required. There are some quizzes in here. You may take them or not as you wish. It simply doesn't affect your grade. I do not grade them. But whatever I do grade, 50% of your grade is going to be the average. Strictly speaking, the arithmetic mean. We add all of them up and divide by the number of tests. Of all the module exams, they're called modules now instead of chapters. All the module exams and the final exams will be added up equally and divided by the number of items, and that'll be your 50% grade. The other 50% of your grade is for the labs that you do. So when I click on assignments, it shows you the exams. The first exam covers chapters 1 through 4. We're not quite ready for that. Unless you're going to be a busy boy and get ahead and get ahead. I have those turned on now. You can see those now. So before we'd have chapter 1 tests, chapter 2 tests, chapter 3 tests. There were typically 10 or 12 tests in each particular one. But now they've reduced it down to, and this looks like in this case we got 5 tests, 5 module tests. I'll keep all those turned on all semester long. Now my policy on the test is they're open book, open neighbor, open curriculum, open internet. You get 3 attempts at each test. So since that's 50% of your grade, try to go in and complete those tests and try to get a good grade on them. There's some stuff, I think I warned you guys last time about, there's a lot of bogus things about the Academy site about averages and stuff like that. Pay no attention to any things on the Networking Academy that tells you what your grade is in the course, because there's stuff in there I don't use. All your grades will be posted in the black book, and they'll appear there. A word about the course feedback form. Cisco does have a business rule or a business requirement that in order for you to complete the course, you must attempt the final exam. Doesn't make any difference what grade you make. You just have to try it. And you have to take the course feedback form. The course feedback form is kind of like a customer satisfaction survey. So when it gets toward the end of the course, and I tell you, well, this is the week we're going to take the final exam, the deans have asked us the vice presidents have asked us to turn on the final exam for about a week. So I think the last day in our course is a Wednesday in October the something. I'll turn it on about a week before, on the Wednesday beforehand. You'll have a whole week that you can complete that final exam. You can do that at home like you do with the chapter tests. Okay, I think I covered everything I needed to about the Networking Academy. So let's see. On your individual machines, last time you cranked up the VMware workstation and you had to double click on that shortcut in the V folder, C:\V. There was 2 shortcuts. There was one called PCA shortcut. There's one called PCB shortcut. If you only clicked on PCA, go back into that V folder today and click on your PCB too, because you're going to need for the 2 labs today, it requires 2 PCs. There's a PCA and a PCB. And my recommendation on those VMwares is if you put them on the big screen's got super high resolution, and the fonts are so tiny you can barely see anything. My recommendation is you put the VMware program on the small screen on the left and put your Terra terms on the right-hand screen, okay? And that way the fonts will be more readable. I'm going to show Terra term in a second. There's a way to increase the font on there because it's a default font's kind of tiny. If anyone has a problem with that, I'll be glad to come around and help you with this. Okay, what I'm going to do now is go through a little walkthrough of this lab and show you the gotchas on it. That was the first gotcha, PCB. I can't get my PCB. It's not going. It's not in my thing. It's not in my VMware. All I have is my PCA. You got to go to that C:\\V folder in the Files Manager, File Explorer, and double-click that one time. You'll never have to do that again once you do that the first time. And if you logged into your same workstation, it remembers it per user. You won't have to do that anymore. If you change to another workstation, later we'll have a lab where you might have to log into your second workstation because there's like one router and two switches. Well, each workstation's only got 2 Terra terms. So if you don't have a router and 2 switches, you need to log into the workstation next to you, and you can use that to plug into the router. Okay, let's see now. I need to, let's see. First of all, I'm going to show my PCAs and PCBs. Let's see. Can I stop this? Can I just minimize this? All right. So here's the configuration for today's lab. We got 2 switches. Now, I pre-wired all the stuff for you guys. All possible from your one's workstation. The workstation is sitting at, you can do the whole lab from one workstation because there's only 2 host machines. PCA, PCB, that's your VMware, PCA, PCB. And your 2 Terra terms. Most of you guys is COM1 and COM3. When you start your Terra term, it'll default to COM1. That's going to be switch 1, first switch. And then it's usually COM3. Sometimes Windows goes kind of nuts with the COM ports. It may be some other number. Like on mine, for example, COM3, I have to use COM4. COM3 is used by something else. I'll use COM1 and COM4. And so you can do everything from one particular workstation. So let's talking about IP addresses. Look at the management addresses for the switches. They're 192.168.1.11 and 1.12. Now look at the IP addresses for the host machines, PCA, PCB. They're 10.3 and 10.4. Now, if we plugged all these things together with a default unconfigured switch, which is kind of like a hub that's fast, no VLANs yet, just the one default VLAN, everything's in the one VLAN, right? By default. Everybody can hear each other's Ethernet broadcast and Ethernet frames. So there's a question later on in the lab. He's going to tell you, try to ping from PCA to S1. He's going to, later on, you're going to make a VLAN 99. You're going to move the switches over to it. But first of all, it's going to be like this. So S1 and S2 will be able to ping each other because they're on the same IP subnet. They're on the same /24, 192.168.1. The 2 PCAs and Bs will be able to ping each other. They're 192.168.10. No PC will be able to ping any switch. No switch will be able to ping any PC. That's normal. You're going to freak out. Oh, I did something wrong. And he asks, why? He says, why? It's because they're on different subnets. Even when devices are plugged in, even an old hub, if they're configured to be on different subnets, they ignore each other. They hear each other's garbage, and they simply ignore it. They won't respond to it. So I'm going to do a very basic configuration of my 2 switches here. Let me minimize this. I have done, let me tell you my suggestion whenever you do a lab, just to make sure the wiring is okay. And I'm doing the wiring, so it's my fault. There's some problem with the wiring. Okay. But for now, we don't allow your germs on the wires. So I'll fix the problems for you. Later on, we're going to give you a baggie. You'll get your own bag of wires, but we're not quite ready for that yet. So all I did on these 2 switches was I gave hostname command S1 to the first switch, and I gave the hostname name of S2 to the second switch. Now here's my trick. Here's my gonzo secret insider tip of the day. Whenever you do any Cisco work in a lab or in the real world, in a production corporate environment, you want to make sure that the wires are plugged in the way you think they are, because 75% of all problems in the real world are wiring faults or wiring errors. I just want to make sure that I did plug my port number 1 from switch 1 to port number switch 2. How can I check that easily? It's our good old friend Cisco Discovery Protocol. So I'm going to use that. I'm going to type show CDP neighbor on switch 1, and he tells us that my local interface port on my switch 1, I'm switch 1, I see a neighbor, he's S2, his port 1 is connected to my port 1. Oh, good, that's what the lab said we're supposed to do. Now, if I flipped it around and changed it to some other number, I would say that it's wrong. So when you have a real complex lab with 3 routers and 3 switches or something like that, and you want to make sure the serial ports and all the Ethernet ports are good, this is a quick and easy way of checking for it. I'm going to go ahead and just do what's in the chart on the front page for now. Before I go and step through the lab as this walkthrough goes. Excuse me. I'm recording this walkthrough here. It's like what's the Statler brothers? Roadhog. You guys know about the Statler brothers? They're a country group, and they had a joke thing called Roadhog, and Roadhog would record. He's going, hope that don't come out. He'd do all this scoffing and stuff. So I'm being Roadhog. Okay, I'm going to configure the switches first, and then I'll go back and configure the PCA, PCB, and we're going to try this testing, ping testing I talked to you about. So how do I apply that management IP address he gives us to S1? Well, first of all, I'm going to go to the privilege exec mode, and then I'll go to the global configuration mode, and then I'll say interface VLAN 1, and he's supposed to be given an IP address of 192.168.1.11. And 255.255.255.0. And then I'll do the no shutdown command. I'll do the same thing to switch S2. So go to the, oh, I forgot to show you the trick. I forgot to show you the trick with the font. When you first start TerraTerm, it's a little small font. So I think David or somebody said last time, I can't see that. I remember first my memory. I made the font bigger. So how you do this, you go to click to setup, and you go to font, and you go to font, and it's going to be 9. It's going to be real small. Just change it to 14, and click OK, and that'll make it more readable on the screen here. Okay, so I'm in S2. I'm in the privilege exec mode. Now I'll go to the global configuration mode, and I'll say interface VLAN 1. And give him his appropriate IP address, which was 192.168.1.12. And then we'll perform the no shutdown command on that. Okay, now I'm going to go back to the show mode here. Control Z is the quicken key I like, no matter how far you have descended into the global configuration mode. I'm config, I'm config IF, I'm config routing or whatever. Control Z will always bring you out very cleanly. So how to type exit, press the enter key, exit, press the enter key. Type exit too many times, you log off. Oh, oops, didn't mean to do that. So just Control Z is what I recommend to get back. And then you get the Cisco annoyance pop out. If you don't like that, you can do that logging synchronous command, and that'll clean up the screen for you when those error messages or those status messages pop up. Okay, so I'm going to type show IP interface brief for short, because is as short as you can type it. Usually on the screen, I use the tab command and I flesh out the command so you can see it. But you're allowed to abbreviate the commands. So, oh, good. I'm 192.168.1.12. I'm up and up. Okay. I'm on the up and up. Everything's cool, right? Let's go to the first switch and repeat the same thing. Show the interface brief. And I'm 1.11. So in theory and practice are the same. In practice and theory often differ, but in theory, I should be able to ping my neighbor's switch. Ping 192.168.1.12. And there's this heart-stopping momentary pause where you think everything's going wrong, but no, everything's fine. Because why did the first ping fail? Because it was the ARP thing. ARP made it. The first ARP request didn't come back. The reply didn't come back before the first ping timed out. If I do it again, it's going to be just great. So switch 1 can ping switch 2. If I can ping him and he has a return path to me, ARP request. I got my ARP reply. Looks like there's a two-way getaway path here, but just to check, I'll ping back 192.168.1.11. So we have pingability from switch to switch. Now let's go into our PCs, our VMware PCs. I'll go to PCA first. Now I put a shortcut on the PCAs called Cisco Lab Shortcut. I'm not sure if this is working on you guys. No, normally you to get to the network control panel, you have to go to the control panel, network, and find a thing that says change adapter settings, something like that. I like to do the shortcuts on there. And also, there's my favorite thing. You can go start run and type ncpa.cpl, which is the network control panel. It'll bring it up for you. I'll do that just to illustrate. I'll do run ncpa.cpl. It's still there because I use it so much. Okay, so here's our one NIC. Now remember, our computers have two physical NICs, but VMware A is mapped to the first one, and VPCB is mapped to the second one. So I'm going to right-click on that and choose Properties, and then double-click on IP version 4, and there may be some other numbers there from somebody on did the lab previously, or you did the lab previously and it's a different IP address in this lab. So the quick way is click the address obtain automatically and then click back, use this IP address, and then you'll be allowed to put in the address. So here's PCA, and he's supposed to be 192.168.10.3. And Windows, if you press the tab key, he said, well, that looks like a class C/24 to me. He puts in the 255.255.2. Oh, we're supposed to put a default gateway on this. Okay, there's no router here. There's no physical router. If we had a router in this lab, it would be the 10.1. The workstations are 10.3, 10.4. The router traditionally gets the .1 address. Okay, so I'll go ahead and put that in there because he said to do it. 192.168.10.1. There we go. I'll click OK and click the second OK. And now let's go to PCB. I'm going to go ahead and bring up the DOS prompt here just to check to make sure IP config. Sometimes with these virtual machines, it's mumbo jumbo black magic VM stuff. Sometimes it doesn't take. Sometimes we got to disable, re-enable the port. That usually fixes it. I'll go to PCB now. I'll repeat it with this address. So let's see, PCB. I'll use the Cisco shortcut, which is exactly the same thing as what I did before. And I want to go to the IP version 4 and place the specified IP address was 192.168.10.4. And I'll put in the 192.168.10.1 default gateway address. Click the first OK, click the second OK, click the close in this case because it's a shortcut, and then we'll bring up the screen and perform our sanity check. It looks like I'm 192.168.10.4. So in theory, now I should be able to ping 192.168.10.3, which was my neighbor PCA, and it worked. And so we'll go back to PCA. If PCB can ping PCA, then PCA ought to be able to ping PCB, and he's 10.4. So we have good pingability. Now, here's going to be a thing in the lab where he says ping 192.168.1.11, which is the switch's address. Uh-oh, bad magic. What's going on? Very different subnets. One's on the 10. Subnet, one's on the 1. Subnet. So even though they're physically connected together, if I change the IP address of switch to be on the 10. Network, it would work just fine. It's just not going to, even though they're physically plugged together, it's like, okay, I speak Yiddish and you speak Portuguese. We can hear each other talking, but we're not communicating with each other. All right, good. Now I can step through and do some of the stuff on the lab. So on page 2 of the lab, we built the network up. It's been cabled. He says configure basic settings for each switch. Let me see. I'm going to go back into my, see if I can allow, where's my mouse? Okay, we're supposed to go into the privilege exec mode, go to give a device name. I did that. Is this one. Disable DNS lookup. What does he mean by that? Let's go in the configuration mode. Here's the way Cisco labs work. They'll tell you how to do it in the Chapter 1 lab. And then when they tell you to do the same thing in the Chapter 3 lab, they don't tell you the command to type. That's the no IP domain lookup. So I'll type no IP domain lookup. That means if you mistype a command, you don't sit there while it hangs for 2 minutes looking for something through DNS, which is not present here. So that's what he means by that, disable DNS. Okay, we're going to apply class as a privileged exec mode password. Enable secret class. Okay, that means when you go from user exec mode to privileged exec mode, you have to know that it's class. Then we're going to assign Cisco as the console password and the VTY password. So line console 0, password Cisco enable. Login, excuse me, login. Now let's go line VTY 0 through 4. I'm going to do backwards because I'm going to show you if you do it out of order, it works, you get an annoying error message. So I'm going to say login, and he's going to say, you told me to allow logins on the VTY ports through Telnet or Secure Shell, but there's no password set yet. Okay, I'll just, okay. Password Cisco. Same thing applied. I just did them out of order and I got an annoying error message. Everything's cool. So that means that when I log out of the switch, I'll have to know the password to Cisco. And when I go to the privileged exec mode, I have to know the password's class. We've set our passwords. If I telnet it into it, you don't have to do that in this lab. Okay, encrypt the plain text passwords. Oh, I misspelled service. Service password encryption takes those. Before I do this, just to illustrate, I'm going to do show run. Show running config. Now we did enable secret class, right? So when we see enable secret, what's that's not class. What's that? That's the encryption of the class. It's the Md5 encryption of the class. All right, it's kind of difficult to reverse Md5 encryption. Encryption uses prime numbers. So if I gave you two 10-digit prime numbers and said, please multiply these numbers together and give me the 20-digit product of these two 10-digit numbers, that's easy. If I gave you a 20-digit product of two prime numbers and said, factor this 20-digit number into the two 10-digit primes that were multiplied together to get it, that is mathematically very difficult. So prime numbers is the basis for all encryption. So I'm going to say, yes, I forgot to show you. Find VTY. Cisco. Password Cisco. There it is in plain text. There's no such thing as enable secret Cisco in the line, but we do have this other command, which I'll go back to the configuration mode, and it was, oh, he's not going to give me that? Okay. Service. Oh, sorry, service password encryption. Service password encryption. And what that does is, let's go back and do the share run command. Now, the classes, Cisco was the password, right? And then you can't see it anymore. So if someone's looking over your shoulder, you have a printout, you're the Cisco guy, you're the system administrator, you're the network technician, network engineer, that joint, you got a printout, or you're looking, no one can see what the password is. They don't have any business getting to that. It's weaker. When we did show enable secret 5, the 5 means MD5, that's real strong encryption. Encryption on the service password encryption is kind of weak. Its basic job is slightly hide the password. Go to the website boson.com, BOSON.com. They sell Cisco preparation practice tests. They have a little utility that will reverse that type 7 password back to the plain text word. It's easy to do this. Then nobody can reverse engineer MD5. It's almost impossible. Probably the NSA, the CIA, they probably do it. You know, the KGB, they can probably do it, but we can't do that. Okay, I encrypted the passwords. Create a banner. So I'll go to config mode, and I'll do banner message of the day, and I'll do a delimiter character, warning, Will Robinson from Lost in Space. So this means that whenever you log into the device, before you even get to log in, they see that message. That's the banner message of the day. So your logger will tell you what to put in your firm. It'll probably say, everything's being logged, warning, authorized users only, stuff like that, whatever the logger's telling them to say. So you've been legally warned. I'll log back in with Cisco. Well, I already configured the IP address. Show IP interface brief. I already did that because I did the ping test earlier. Shut down all interfaces that will not be used. I'm going to skip that for now. Set the clock on the switch. I'll skip that. That's okay. Save the running config. That's important. I've done a lot of work here. I'll go to the privilege exec mode because you can't save it when you use exec mode class. And I'm going to do copy, run, start. Is what you're allowed to abbreviate it. That actually means copy running dash config start dash config. And now the configuration is saved for that. Now I'll repeat this on the second switch, and I'll skip some of this nonsense I did on the first switch because you already saw this. So on S2, I already gave it the device name. I'm going to skip the passwords and the encryption and stuff. I'll just save it. I'll just save it. Okay, step 3, configure the PC host. Well, I did that. They're configured. Now, step 4, confusing, because it says, can PCA ping PCB? Well, yeah, they're on the same IP subnet. Can PCA ping S1? No way. They're on different, even though they're physically plugged together, their IP addresses are not compatible with each other. Yiddish, Portuguese, no, can't talk to each other. Can PCB can ping PCA only. Back at APCA, S1, S2 can ping each other, but they can't fit to the hosts. So why were the pings unsuccessful and the ones that didn't? Different IP subnets. Now we're going to do some VLAN stuff. So we're supposed to go to S1 and create some VLANs. Oh, when I do a show VLAN brief, we have our normal #1 VLAN and all 24 fast Ethernet ports and all 2 gig ports are connected to it. All right. And there's no more VLANs present except these stupid default ones, which we don't use any fiber distributed data optic cable. We're not using any token ring. We're not using any ARPANET. We just use Ethernet these days. That's old stuff because this was developed back in the 90s when that stuff was still coming. Okay, so we're going to create some VLANs on switch 1. And he says go to the config mode and say VLAN 10. And name operations. Ooh, I should have capitalized that. Name VLAN 20. Name parking lot. That looks like an underscore. VLAN 99. Now that's what we're not going to use for our management stuff. So I'll give it the name management. Sometimes people put it manglement because these are the C3 types, the upper management guys. They're idiots. They have no technical knowledge. They tell us to do something. We have to take their big plan and try to come up with the iOS code to make the devices communicate with each other. Okay, now I'll name. It's VLAN. VLAN 1000. Gosh, we're getting pretty big here. Running out of numbers. Well, we got all this numbers. We got about 1,000 we can use, and that's going to be named native. We're going to make it the native VLAN. And then we'll do the same thing on the second one. Just for fun here. Oh, now there's a VLAN.dat file. Before I created any VLANs, there was no VLAN.dat file. All the VLAN information you create, names, numbers, are stored in the VLAN.dat file. So as soon as I made that first VLAN in addition to the default, he made that. Now there's a thing called VTP, which it's not an objective here, but What happened there? What are these wrong numbers? Did I use the wrong number here? I did. Oh, that must be in there from a previous lab. I didn't erase it or something. All right. Let's see here. I thought I checked for VLAN dot file. Well, let me try this. Let's go into unexplored territory here. Excuse me, and let's delete the VLAN dot dat, and then do show VLAN again. Got to reboot. It doesn't work. Got to reboot it. Okay. I'm just going to create the VLAN 99 on this one. Is he already there? I'm going to create the VLAN 99, and this is why you need to delete the VLAN before you go in the file. Somebody's previous garbage is going to confuse you and get in there. So I'll go to config T and say VLAN 99 and name management. There we go. Now, when I did the show VLAN here, were the ports reassigned? All the ports are still assigned to VLAN 1. Okay, so I don't have to reboot it. We can go in here. Okay, so we create the VLANs. What ports are assigned to the default VLAN? Every one of them. We haven't moved any ports over yet. VLANs is a two-step process. I create VLANs, like 10 for faculty, 20 for students, 30 for guests. Then I move the ports that the students are plugged into the VLAN 30. I move the ports that the faculty are connected into 20, whatever the appropriate ports are for those. So now we're going to do this. We're going to assign a VLAN to multiple interfaces. Let's go to S1, and I'm on bottom on page 4. Now, S1 should still be able to ping S2, and PCA should be able to ping PCB. We haven't changed any port assignments yet. Let's go to assign a VLAN to multiple interfaces. So on S1, we're going to use the trick of the interface range command. In this case, ports 1 through 24 are supposed to be assigned to VLAN 99. And that would be real hard to go interfaces faster than 0. Switch port, mode, access, all that stuff over and over and over again for 24 of them. So the interface range trick allows you to do this. He's going to say, be in the config mode. And say interface range, fast Ethernet, 11 through 24, 0/11 through 24. So now whatever I type is going to do all those 11 through 24 in one swoop. I want to do it 13 times or whatever this is. So switch port, mode, access, switch port, access, VLAN 99. Check with show VLAN. Buh. Look there, I moved a bunch of port stuff over to VLAN 99. So now the people in the default VLAN 1 can't even hear anything that the people that are plugged into the ports that have been signed to VLAN 99. They're totally isolated from the other, as if I take a fireman's axe and chop the switch into 2, and they were not connected to each other in any fashion whatsoever. Okay, step 2, remove a VLAN assignment from an interface. So let's go to port 24. I'll go to config mode, interface, fast Ethernet 0/24, and say no switch port, access, VLAN. So what happened to VLAN port? What happened to the status of port 24? Show VLAN brief. He's back in the default where he was. He was here. I did 11 through 24. He's back. Most iOS commands can be reversed or wiped out or back to normal, but just repeat them and putting the word no in front of it. No, 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 no. Put it back. So he's associated with that. Now let's remove a VLAN from the VLAN database. Add VLAN 30 to interface F24 without using the global VLAN command. I think I mentioned this during the lecture. As a courtesy to you, if you assign a port number to a VLAN that does not yet exist, 30 no longer does not yet exist, instead of saying, oh, he's going to go ahead and as a favor to you, as a courtesy, he's going to go ahead and create that. So I'm supposed to go to interface, config T, interface fast Ethernet, interface fast Ethernet 24. And I'm going to say switch port access VLAN 30, which does not yet exist. He created it for me now. What is his name? I didn't give it a name. 30 has been created. He gets the default name. Whenever you create a VLAN, if you don't do that name, I'll come back and do it later. You get the default name, VLAN 0030. That's the default name. Okay, now I'm supposed to get rid, be in the config mode. And I'm supposed to get rid of that VLAN. I did VLAN 30 to create it. How do I get rid of it? No, VLAN 30. That should get rid of it. Okay, now we just show VLANs again. Oops. Oh, I have my caps lock on? Yeah. Lose mine. Where is port 24? It was there a second ago. Where the heck did it go? When you have a port assigned to a VLAN and you delete the VLAN, every port that was assigned to that VLAN goes into a no man's land inconsistent state with no connectivity. Well, the green link light's on. There's host attached to it. They can't communicate. So the danger of deleting the VLAN is all of a sudden they can't communicate anymore. There used to be a thing called, there still is a thing called VLAN trunking protocol, VTP, that's no longer a CCNA objective. And if you bought an old switch off of eBay and you plugged it into your production network, there's a thing called a configuration revision number. You could wipe out your entire infrastructure in like 1 second. That's a resume generating event, I tell you. All of a sudden, all the VLANs are deleted off all the switches and no one has a record of it because the device you bought was been used in some company and had a higher revision number. Oh, we don't want that to happen, no. So, but whenever you buy an old switch and you plug it into your, of course, you're going to bring it to the company, you're going to plug it in, mess with it. Erase it first, delete the VLAN.dat file, delete the configuration registry number, or you're going to mess it up bad. And then you're going to spend hours and days fixing that up. Oh, no, you won't. You'll be gone because you just brought operations to a halt. So have a working backup, Make sure your resume is up to date. Okay, how can I correct that problem now? I could say config t interface fast Ethernet 0/24, and he tells us to issue the no. Where'd it go? No switchboard access VLAN. What should that do to port 24? What did it do before? Popped it back to VLAN 1. Where is it? There it is. It's back. 24 is back to the default VLAN. Okay. So let's resign. So object lesson before removing a VLAN from the database, make sure all the ports are reassigned. Otherwise, they're going to drop into inconsistent no man's land, not connected to anything. And if it's an important server or the vice president of marketing, you're going to feel the heat. Now let's do the trunking. The trunking was our way of if I had 3 VLANs and I didn't have trunking, or we had 4 or 5 VLANs. So I have 5 VLANs on switch 1 and 5 VLANs on switch 2. If I didn't have trunking, I have to run 5 Ethernet cables between 5 ports at switch 1 to 5 ports at switch 2 to get connectivity for all 5 of these subnets. And that's too many ports. We're using up too many ports. So we do what the phone company did. The phone company figured out a way in the 50s of putting 24 voice communications on 1 wire, so they didn't have to run 24 wires between Dallas and Fort Worth. We're going to do that. Thank you, Big Brother. He's watching us. Everything is being recorded. If you want a backup of your hard drive, ask the NSA. They'll give it to you. Yeah, NSA. I lost my bag. Okay, so we're going to go to. I'm in the sort of the top third of page 6 now. Oh, we're almost done. Good. So I'm going to go to switch 1 and show interface trunk is the command. Show. Oh, I have a caps lock on. There are no interfaces other than trunking mode. Okay? And if we don't show VLAN, all the ports are present and accounted for. And here's my secret gonzo insider tip that I tried to show you guys Tuesday on the packet tracer, but it doesn't. The packet tracer does not implement this command correctly. Show interfaces status. I love this command because at a glance, it shows you everything you learn from typing show VLANs. It shows you everything you learn from typing show interface trunk. There's no trunking ports yet. We're going to go to port 1. We're going to make it trunking. Right now, port 1's a VLAN 1 on both of them. We're going to make them trunk up, and then we're going to see how this changes. Okay, so he tells us on part 4, step 1, to set port F1. We're going to start it to become a trunking port. So I'll go to configuration mode, interface fast Ethernet 0/1, switch port, mode, dynamic, desirable. Which is not the default for these switches, is dynamic auto. Dynamic desirable makes them even more aggressive. Like the mostly peaceful protesters. They're very aggressive. Okay. What happened on S2? I got some link messages here. Pow, 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 pow. Okay, now the lab says, type show VLAN brief. Port 1's gone. It's not an access port anymore. Let's do show interfaces trunking. Port 1 is trunking now. And what about switch 2? Did we type any command on switch 2 about it becoming a trunk? I'm going to use my alternate command here that I love better. Show interface status. Show interface. Oh, well, this doesn't work from the user exec mode. I got to be in the privileged exec mode. Show interface status. Saturn. Look what happened to port 1. It's trunking now. It was access port before. It was VLAN 1. Now it's trunking. I didn't type any command on the switch. He trunked up because S1 says, I overwhelmingly desire to become a trunk with you. Will you become a trunk with me? And we had that chart in the thing. If switch 2 is dynamic auto, which it is, and switch 1 is dynamic desirable, which it is, they will trunk up. Now the default is they're both dynamic auto. They did not trunk up. All this time they did not trunk up. If I had simply gone to switch 1 and said switch port mode trunk, unconditionally become a trunk, the same thing would have happened. Okay, now can S1 ping S2 over the trunk? Be it S1. And let's see. This is why I like to tear the front page off the lab. When you get to the next part of the lab, I can refer to the front page. What was the IP address for S1? Oh, yeah, this. Okay, shall I be able to ping 192.168.1.12? Yeah, it works. It works. I can do it. But we still have connectivity over the trunk now. The trunk is encapsulating all these separate individual ones. Now, can S1 ping, can PCA ping PCB? If we didn't jack with their trunk, the port assignment, maybe. Let's see, what did we do here? Let's go back and see. Go to PCA. And I was going to ping 10.4. Yeah, they can ping. So they're communicating over the trunk just fine, like they did over. So here's the big picture, guys. Why do we use trunking? One wire, infinite number, hundreds of VLANs over one wire. If I got 10 VLANs, I have to run 10 wires and consume 10 ports on switch A and consume 10 ports on switch B that are no longer available for my host machines. I'm doing one wire. So that's why we use trunking. Now we're going to manually configure it. Let's do them. This is what I like to do. I don't like auto negotiation stuff. I prefer, the reason is because of previous history with Cisco and other manufacturers' devices, that the auto negotiation would sometimes give us problems. Like one port would negotiate to be half duplex, the other port would negotiate to be full duplex, and you get a bunch of late collision errors and a bunch of problems. I prefer to configure things explicitly. So I'm going to do this on the switches. I'm going to go back to the switches. Go to the first switch. Go to the second switch. I'll show you what I would type if I was setting this up. If I was writing this lab, this is the way I would do it. So config T, interface fast internet 0, /1. So the normal command would be switch port, mode, what are our choices here? Unconditionally become an access port if it's going to go to host machine. Host machines cannot understand trunking. If you send them trunked frames, they will not understand them and they will not be able to use them. Trunking port, well, if I'm going to another switch, yeah, I want to trunk unconditionally. Dynamic is, well, yeah, the default mode is dynamically negotiate. I'll tell you why I don't like dynamic and why I like to cut it off. Some jackleg technician working in the help desk department who just took a Cisco course and thinks he's a hot network guy will try to plug a switch he bought off of eBay under the desk there and try to make his port become a trunking port. And now he's got access to the entire company instead of the very carefully strategy of the security that the guy set it up where the people in the help desk, we can't get an access to the financial files and stuff like that. We'll put them on another VLAN. Well, if he makes himself a trunking port, he's got all the VLANs. Okay, so what I'll have to do is switch port mode trunk unconditionally, and I'll do the same thing on the other one. Config T, interface, fast Ethernet 0/1, switch port, mode, trunk. Now they're unconditionally trunking. They were before, they were trunking, but they were as a result of negotiation. It was not unconditional. Now I made it unconditional. Now the last thing is the trunk VLAN, the native VLAN. We made a special VLAN 1000 to be the native VLAN. As a reminder, the purpose of the native VLAN is to be the one and only one VLAN you are allowed to have with no 802.1q encapsulation where they split the frame up and they put the tag number of the frame in it. By default, it's always VLAN 1. You can make it any one you want. Normally, we move it to, typically on our labs, we move it to 99 and make that the management VLAN. In this case, we made it 1000. So I'm going to go to, if we do, oops, let's do the switch one. Show interfaces trunking. See they were trunking. 802.1q encapsulation. Native VLAN is 1. We're going to change that. And I'm going to show you this gauche that will upset you when you do the lab. So switch port, oops, go config T. Interface fast Ethernet 0/1. Switch port, trunk, native VLAN would only be 1, and we're going to get 1000. And any second now, oh, look at there. Oh, I'm getting annoyed, Cisco annoyances. I'm getting all these nasty grams. So how can I get rid of that? I almost can't type anything because the messages are coming so fast and furious here. I'm going to do the same thing on this. So I'll do config T, interface fast Ethernet 0/1. But, oh. Switch port, trunk, native, VLAN 1000. And the messages stopped. The old joke, Halloween joke. The coffin stopped. I'll tell it to you Halloween. So the messages have stopped. Everything's consistent now. And it's taking a few seconds to do this, I guess. Show interfaces. Trunk. Oops. More characters. VLAN 1000. Okay, we check to make sure it matches with show interfaces, trunk in. They're both 1000. And he went through a little message, a brief period of being upset, inconsistent, blah, blah, and then he settled down, and the messages stopped. So why would you want to change the native VLAN on trunk? Well, let's move everything off VLAN 1 because we're stuck with it. We cannot delete it. We cannot rename it. Let's use VLAN 99 for our management VLAN, make it the native VLAN. Let's use 10, 20, and 30 for our faculty and students and guests. Move everything off that native VLAN 1 because that's easy. That's the most attractive target for the hacker guy. I'm sorry. I'm supposed to call them hackers anymore. And we call them malicious users. No, that makes them feel bad. Now they're threat actors. The threat actors that are coming and breaking into your network. Okay, now this last part here, what should you do whenever you delete a switch or whenever you're ready to, when you're finished with the switch and you want to finish up with the lab? You're going to get the same one when you come in next Thursday. You're gonna eat your own dog food, okay? But in the second 8 weeks, you guys that are in the 4 course, we're going to have another Cisco course on Mondays and Wednesdays. They'll be using the switches. So as a courtesy to these guys, erase your switch when you're done. So they don't have to, they can't erase a switch yet. They don't know nothing about this stuff. So how do I make sure a switch is erased? Well, there's a VLAN file present because I created a VLAN. So I'll type delete VLAN.dat. And then I'll erase the startup configuration. And that's the one command that you can't. I say erase star, you won't take it. Normally abbreviations are accepted. But this is a dangerous command because you're blowing away the configuration of the device. So I have to say erase star and touch the tab key and press enter a couple times to make sure. Now that switch has been erased, and then I'll do the reload command. And occasionally you get this. You type reload, system configuration has been modified. If you type yes right now, he'll unerase it and put it right back. So I'm going to say no, go ahead and reload and don't save it. And we'll do the same thing on this too. There should be a VLAN.dat file present here. And then erase startup configuration. Well, why did he not prompt me on the second switch? What did I fail to do on the second switch that you should do every 10 lines or so? I did not do the copy run start on the second switch. So he didn't prompt me that, oh, you have something and it doesn't match what's in the startup configuration file. He didn't prompt me. So not everybody. Okay, and the reflection questions on the last part, you don't have to do the reflection questions. Okay, so you guys now do this lab. And if you have any, first thing to do is make sure your PCA, PCB are hooked up and going good. And hold on, I got to stop the walkthrough recording here with the mouse that responds.